Wastewater treatment. The brewery's own wastewater treatment facility is below ground on the company's property. A part of the electricity necessary for the brewery is produced by water power, using the level difference. The wastewater treatment facility can treat an equivalent amount of water to that required for 90,000 to 100,000 inhabitants. The facility is designed for a maximum of 2,100 cubic meters per day of wastewater. In a normal case, it handles 1,300 cubic meters per day. The facility consists of a 3,000 cubic meters of mixed and balancing reservoir. In the brewery itself, there is an upstream 8 mm rake installed with a 1 mm sieve width. After the mixing and balancing reservoirs, 10 SBRs, that is sequence batch reactors, are installed with a total volume of 4,000 cubic meters. The pollution load is between 4,500 and 6,500 milligram CSB per liter in average operation. About 100 milligram nitrogen and about 18 milligrams phosphorus is found in the wastewater. Finally, after the biological clearing, there is a membrane filter system installed, which covers a filter area of about 600 square meters. The CSB volume at the outlet is 30 to 40 milligram per liter. Nitrogen and phosphorus are no longer present after the treatment. The downstream membrane technology ensures that the finished treated water is absolutely free of fine solids and hygienic. It is directly led into the river Metma. The sludge produced in this process is dried and conveyed to silo trucks. Loading is monitored with a solvent which is installed above the lorry silo at each of the individual cells. They turn off the sludge conveyor if the truck containers are full. In addition, a temperature sensor is installed which determines if there is heating caused by embers in the dry sludge. A temperature level which could lead to explosion or fire must be avoided. If it becomes too warm, the facility is flooded with nitrogen in order to snuff out potential fire sources. In the SBR, the wastewater is aerated and left to sit, so that the sludge can precipitate out. In order to determine the level, a prosonic M ultrasound sensor is used for each SBR. There is a pressure measurement device in the tanks to carry out hydrostatic measurement. Oxygen measurement and optical turbidity measurement are installed here in order to determine the current load of solids. The sludge dryer has 3 temperature sensors which monitor drying temperatures. The Gamma pilot, installed on the outside of the tank, measures the level. The device consists of a source and a measurement unit, which is mounted on the outer side of the tank. The EMF device determines the correct volume needed for the dosing of the precipitant to feed into the inlet floating decanting system. An oxygen sensor is installed on the dryer next to the differential pressure sensor. The measurement ensures that no flammable gas mixture can be established in the dryer. The oxygen sensor is supplied and assessed by a Liquisys M transmitter in a separate unit. Pressure measurement at the inlet is protected against the heat by a siphon. All media, from sludge to cleared water, is pumped to the relevant containers in the central pumping station. The complete area is monitored by a Promac W EMF and is completely automated. In order to protect the pump from running dry, different sensors are used. An older Nivo compact is installed in front of this wet sludge pump. The long path under the SBR contains the central media distribution. This includes, among other things, Promac W with a large nominal diameter. The inlet to final filtration is monitored by a Promac W as well as a pH measurement in the overpressure outlet. Membrane filtration is installed with a 4-chamber system. Media supply is extensively instrumented. Filtrate transport is done through the membrane to the interior. This is done through a vacuum imposed on the membrane. The level in the membrane chambers is hydrostatically monitored with a Cerebar T sensors. Because the membrane is sensitive to pressure as well as vacuum, the outlet lines have a Cerebar pressure switch to prevent overpressure. In addition, for each chamber, a Cerebar M PMC is installed for vacuum monitoring, and a temperature safety switch is installed which shuts off if temperatures are over 40 degrees Celsius. The flow is measured with the ProMag W. This overpressure measurement is necessary so that the pump is not damaged during reverse rinsing, which takes place every 10 minutes. During reverse rinsing, the majority of solids are blown off and the membrane is exposed again for the following filtration process. This liquefant FTL 260 monitors the deepest portion of the wastewater treatment facility. If the liquefant provides a notification, this means that somewhere a large volume of liquid has leaked out. The facility is completely surrounded by a thick basin in which this liquid can be retained. If the liquefant provides a notification, all facilities can be brought to or locked into a secure state. Also, in membrane filtration, a pump protection switch is deployed in order to prevent pump damage by dry running. The air volume measurement for primary treatment in the SBR is done with the ProWhirl Vortex flow sensors. Pressure and temperature sensors are installed in the same lines. These sensors are needed for compensation of media variations. We see on the right a phosphate measurement device designed by Endres and Hauser STIP. The probe is designed as a submersible probe and is used in the outlet in order to check the remaining phosphate volume.